Hi grade 9s and welcome to WorksheetCloud Maths. I hope you're all well today and you're ready for another exciting lesson. Okay, so welcome back and let's have a look at what we've got in store. Okay, so we're going to be doing transformation geometry and it is actually our fourth lesson in this series, and today we are going to be looking at reflecting a shape across the line y is equal to x. So let's start. So remember, to reflect a shape across the line y is equal to x, we've got to use the Cartesian plane. And to plot y is equal to x is exactly that, is whatever value x is, y has the same value. So let's start at the point of origin where the two axes cross at naught, and that will be our first point because where x is naught, y is equal to naught. Remember, we always put the x value first. So where x is 1, y will be 1. Where x is 2, y will be 2, and so on. So x is 3, y is 3, x is 4, y is 4, and x is 5, y is 5. So then we join those dots to form a diagonal line through the points of origin. And remember, it doesn't only go into the first quadrant, but it goes down into the third quadrant too, where x is minus 1, y is minus 1, and you can carry on going down the line. But I think you see what I'm saying, because if we were going to go into the second quadrant and we would go where x is minus 1, y is 1, it would mean that x and y were not equal. So that line is not y is equal to x. Okay, so we're going to be dealing with this diagonal line and we're going to be looking at reflecting a shape across that line. So first thing is, let's plot a shape. We're going to plot triangle PQR, where the vertices are P minus 7, 6, Q minus 3, 4, and R minus 5, 2. Okay, so let's plot the first point. There's P where it's minus 7, 6. Then we're going to plot Q, which is minus 3, 4. There we go. And then we're going to plot R, minus 5, minus 2. And there is point R. Okay, minus 5 and minus 2. Now, those are just points on the Cartesian plane for now, but if we join those points, we will form a triangle. So join point P to point Q, Q to R, and R back to P, and there you can see that it is a triangle, and we have joined the points that we were given, and remember those points become the vertices of the triangle. So now, we're going to draw in the line y is equal to x, and remember just now we looked at that line. It goes through the point of origin and carries on up to the right and down to the left in the first quadrant and the third quadrant, and making sure that it is where x and y are equal. The coordinates will be the same. So there is our line, y is equal to x, and now what we're going to do, we are going to reflect triangle PQR cross line y is equal to x to give its image triangle P1, Q1, R1. Alright, so what are we going to do? If we're going to reflect, we interchange the coordinates. So instead of P being minus 7, 6, it's now going to be 6 minus 7. So there you can see we are on point 6, or where x is 6 and y is minus 7. And that will give us our point P1. Now to do Q1, it's going to be exactly the same. Instead of minus 3, 4, it now becomes 4 minus 3. And as you can see, x is 4 and y is now minus 3. Whereas in this one, x was minus 3 and y was 4. Okay, that gives us Q1. Then R1, we're going to do the same thing. Instead of minus 5 minus 2, we're going to go minus 2 minus 5. So there x is minus 2 and y is now minus 5. And that will give us R1. Again, those are just points on the Cartesian plane at the moment, but to make the shape, we have to join the points. So we join P to Q, Q to R, and R back to P. And we get a triangle. And we get the image of triangle PQR being P1, Q1, R1. Now, you might just look at it and say, that really doesn't look like a reflection, doesn't look like the same triangle, but if you had to fold your Cartesian plane along the line y is equal to x, you will see that the one triangle P1, Q1, R1 fits exactly on top of PQR. And I'd love you to try it for yourself so that you can prove it to yourself that this actually is right. Plot these two triangles, draw your line y is equal to x, fold your Cartesian plane along that line, and even if you indent the one a little bit, you will see that it fits exactly on top of the other one. So if you had to fold this, that line would go directly on top of that line. Okay, the same with QR would go directly on top of this line, and that one will go directly on top of that line. Okay, because remember, it is a reflection. So it is, if you put a mirror up across the line y is equal to x, you will see that the triangle P1, Q1, R1 is exactly a reflection of PQR. So it is its image in the mirror. All right. Okay, so what are the coordinates for each vertex in triangle P1, Q1, R1? Well, we've already said that because we had to reflect it. So P1 instead of minus 7, 6 becomes 6 minus 7. Q1 instead of minus 3, 4 becomes 4 minus 3. And R1 instead of minus 5 minus 2 becomes minus 2 minus 5. All right. Okay, so we can say that the rule for reflecting across the line y is equal to x is xy so that y becomes x. xy where y becomes x. So that is what we call interchanging the one node of coordinates to the other. Okay, right. So now I want you to try something. Okay, here's a Cartesian plane, and we've got point A, point B, point C, point D, and we are going to join those points to form a shape. So we draw a line from A to B, B to C, C to D, and D to A. Right, now you can see that there is a shape there, and I'm sure you all know what it's called. There are a couple of things for you to do now, because you have to do all of these on your own. So instead of pausing the video each time, let's go through all the things you have to do. Then you pause the video for a long time, work it all out, and when we come back, we will go over it. So first of all, what shape has been created on the grid? Write the coordinates for each vertex in that shape. Draw in the line y is equal to x. ABC is reflected across the line y is equal to x to give the image A1, B1, C1, D1. Write the coordinates for each vertex in the image and prove that the two shapes are congruent by working out their area. Now remember, when we looked at the triangle, I said we could work out that they were the same by counting the little blocks in the triangle, and if they were the same little blocks, then the area would be the same. That means that they are congruent shapes. Okay, so what you have to first do is figure out what kind of shape this is, and you would have already done area and perimeter and looked at what the formula for area is of this shape, so you can then just apply it. So see that one as being a little bit of revision. Right, now that's what you have to do. I'd love you to pause the video and then you work through it on your own, and when we come back we can see how you did. Right, let's see how you did. Okay, there's the shape. What shape has been created on this grid? It is a cut. You are absolutely right. Okay, what was the next question? Write down the coordinates for each vertex in the shape. All right, so we've got A is going to be minus 3 and minus 5 and 5. Okay, sorry, minus 3 and 6. Sorry about that. B will give me 2 and 7. Just hold on a minute. Guys, it is 2 and 8. C is 9 and 6. And D is 2 and 4. Okay, that should say 4. Let me just correct it. There we go. It's been corrected. So D is 2 and 4. What was the next thing that you had to do? Right, you have to draw in the line y is equal to x. Now remember, y equals x goes through the point of origin where the two axes cross, and then where the points are all the same. So y is the same as x at every point. So that is what your line y is equal to x should look like on these axes. on the Cartesian plane. And the next thing you have to now do is you have to reflect A, B, C, D across that line, y is equal to x, to give the image A1, B1, C1, D1. Okay, so what are we going to do? We're going to start with A, and we've been given at the A coordinates, but remember we interchange them. So A1 now becomes 6 and 3. So let's have a look. There's 6 and there's 3. Okay, so that is now A1. Where's B1? It will be 8 and 2 because it is actually 2 and 8. So now we go x is 8 and y is 2. All right, so there we go. And that will be B1. Then we have to look at where C is 9 and 6. And that's up there. There you can see it now becomes 6 and 9. Okay, because we interchange the coordinates. And then D is 2 and 4, so D1 must be 4 and 2. There we go. D1 is 4 and 2. Can you see how we've got the 4 points? And it looks like it's going to form the same shape, but we can only see that when we join the points, because at the moment those are just 4 points on the Cartesian plane. So you had to join the points up, A to B, B to C, C to D, and D back to A. Okay, so that means you have reflected A, B, C, D to the image A1, B1, C1, and D1. All right, what is the next thing that you have to do? You have to now write down the coordinates for each vertex. And as we said, A is 6 minus 3, B would be 8 and 2, C would be 6, okay, we're on 6 and 9, and D would be 3 and 2. It should be 4. Sorry, let me correct that one too. I've corrected the coordinates. So D was 2, 4, and now it becomes 4, 2. All right. So what was the next thing that we have to do? Let me just correct it there again. Right. So the next thing that we have to do is we have to prove that these two shapes are congruent by working out the area of each of them. So if the two shapes have the same area, it means that the sides are the same length, and it means that the two shapes are the same. They are congruent. But what we're going to do is we're going to clear our page so that we've got space to do the working out. I'm sure you had enough space on your paper and you have just worked out underneath. Okay, so let's have a look. So proving the two shapes are congruent by working out their area, we need to work out what the area of a kite is. So A, B, C, D, it would be half the base times the perpendicular height. Now, remember, in this case, we need to divide the kite across like that, so to those two points, and then we have a triangle here, and we have a triangle here. But our height goes right the way along. So that is our base, and instead of going this triangle and then that triangle, which you can do, and it will work out exactly the same, we can go the base of each triangle times the heights put together. So the base of this triangle times this height, the base of this triangle times this height, we might as well just say the base times the whole height, because it would work out to exactly the same. All right, so our base, how much is our base? And we're going to use the blocks as just units. So they're not centimeters or millimeters or anything like that. So let's count how many units we have. 1, 2, 3, 4. Okay, so the base would be 4. What is the height? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Don't forget that last one, because that point is right on the next line, so that is a whole unit. So we've got the base as being 4 and the height as being 12. So we're going to say half times 4 times 12. You can go 4 times 12 first, or you can go half of 4 is 2 times 12. It's going to give you the same answer, and that's going to be 2 times 12, which is going to give you 24. Okay, now let's just say we worked it out as two separate triangles. The base is still 4, and the height would be 1, 2, 3, 4, 5. So the base 4 divided by half is 2. 2 times 5 is 10. So keep 10 in your mind. So we got the same base, and we're now going to do 1, 2, 3, 4, 5, 6, 7. So half of 4 is 2 times 7 will be 14. Remember, this area is 10, this area is 14. It will still give us an area of 24. Right, but we can't leave it there, because now we have to find out whether the area of the other kite is the same. So let's see. But area of A, B, C, D, 1, A1, B1, C1, D1, and it's going to give us the same formula. We've got to use the same formula. It is also a kite. So let's work out. We've got this is the base, and we can use this as the height, and we'll double check it again to work out with each triangle as well. So if we look at the base, here, 1, 2, 3, 4. Okay, our base is 4. What is our height? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so our measurements are the same, but let's go through the motions of working it out. So it's half times 4 times 12. 4 times 12 is 48, and half that is 24. Or you can say half times 4 is 2 times 12 is 24. Let's see if we can work it the other way. If we go this triangle and then this triangle, I'm sure you know it's going to be right, but just humor me. Okay, so 1, 2, 3, 4. Half of that is 2 times 1, 2, 3, 4, 5. 2 times 5 is 10. And then we work out this triangle area, and that's 1, 2, 3, 4, obviously, because it's the same base. 1, 2, 3, 4, 5, 6, 7. Okay, so half of 4 is 2 times 7 is 14, plus the 10 from the other triangle still gives me 24. Have a look. Area of A, B, C, D is 24. Area of A1, B1, C1, D1 is also 24. So we can safely say that because the areas are equal, the two shapes are congruent. Now guys, there's an activity that is attached to this lesson. Please do the activity, and it's just more practice of reflecting a shape across the line where its y is equal to x. So the line y is equal to x. Okay. Also remember, if you have any queries or any questions about anything that has been done in this lesson, to email grade 9 at WorksheetCloud.com. And also you can go back to the beginning of this lesson and go through everything step by step and see how to reflect a shape across the line. Okay, it can get quite detailed or quite not difficult. It's never difficult, but it can get quite confusing here where one shape crosses over another, but you can also have a lot of fun with that. Okay, so you try maybe making up your own shapes, reflecting them across the line y is equal to x, but like I said, please don't forget to do the activity that is attached to this lesson. Right, thank you so much for watching, grade 9s. I hope to see you again soon, and I hope you have a lot of fun doing the activity that is attached. So bye-bye for now, and keep well until next time.